So the simplest primary amines are named in variations of alkyl amine. So if I have CH3, CH2, NH2, that's just simply ethylamine, all one word. So if our R group can be named just as a alkyl group, like ethyl or methyl or isopropyl or something like that, okay, we just name it simply like that. So similarly, if I have pH, CH2, NH2, remember benzene with a CH2 is a benzyl group, so that means this compound is benzylamine. Don't confuse that with aniline, which is NH2 attached directly to a benzene ring. We learned about that in our aromatic chapter. If we have a little more complicated amine, something that can't just be named with an alkyl group, we name it as usual, but drop the final E and replace it with amine, like we've done a lot of times before. So look at this compound right here. It's a cyclohexane. If I number around the ring, starting at the one that the nitrogen is attached to, right, we've got 1, 2, 3, 4, 5, 6, 2 methyl groups on carbon 4, so it's 4,4-dimethyl cyclohexane amine. Okay? So where it would have just been dimethyl cyclohexane, becomes dimethyl cyclohexane amine. If we have a diamine, okay, like this one, 1, 2, 3, 4, 4 carbons, 1, 2, 3, 4. NH2s on carbon 1 and 4, that's 1,4-butane diamine. There's no reason to drop that final E unless your suffix starts with a vowel. So diamine, right? Butane, diamine. It's all one word. If we have a molecule with other functional groups, we use the amino prefix to represent the NH2 group. So if I have butanoic acid, 4-carbon carboxylic acid, with an NH2 group attached to carbon 2, that's 2-amino-butanoic acid. The NH2 group on a benzene ring with something else, right? Here's benzoic acid. The NH2 groups come out to 2,4-diamino-benzoic acid. Here's 4-amino-2-butanone. Notice that the ketone is the last thing we talk about in the molecule, right? It's the last part of the name, so that's what gives priority to the numbering. So even though the NH2 is attached to an end carbon, because we're naming this as a ketone, we number from the end closer to the carbonyl. Those were all primary amines. If I have a secondary or tertiary amine, it's pretty simple if they're symmetrical. If we have 2 of the same R group or 3 of the same R group, we just use di or tri as prefixes before the alkyl group. So here's nitrogen with 2 phenyl groups on it and an H, so that's just diphenylamine. Here's triethylamine, very simple name. If you ever have the misfortune of coming across triethylamine, that's one of the compounds that's given off by rotting fish, so you can imagine what that smells like. If we have a mixture of different alkyl groups, use a capital N as a locant, just as we would a number in naming things, right? And then list each of them in alphabetical order. So what we can do, right, here's a nitrogen with 2 methyl groups and a propyl group attached. The base compound is propylamine, right, since that has the most carbons to it. We then give each of those methyl groups as a substituent. So it's N,N-dimethyl propylamine. Again, here's a nitrogen with a methyl, an ethyl, and a cyclohexyl group. N-ethyl and methyl cyclohexylamine. The main base name is cyclohexylamine. The substituent with the most carbons to it becomes the base name. And anything else is named as substituents off of that N. Heterocyclic amines, we know what cyclic means, but if it's heterocyclic, it has a heteroatom inside of the ring. So as actually one of the ring atoms, so sort of replacing a carbon within the ring. So pyridine is just like benzene, except we have replaced a carbon with N. So pyrrole is a 5-membered ring with 2 double bonds and an NH in it. We'll talk more about pyrrole. Pyrrole is actually aromatic. These other ones are important. We'll talk about them a little bit as we go on, but what I do need you to do is to be able to know the structure of pyridine and pyrrole. I don't think it's unreasonable to have you know 2 of those, but pyridine is a 6-membered aromatic nitrogen heterocycle. Pyrrole is the 5-membered aromatic nitrogen heterocycle. These other compounds are found a lot of places. The non-aromatic versions of pyridine and pyrrole are piperidine, which is just like a cyclohexane with an N, and pyrrolidine, which is like a cyclopentane with an N in it.